Next, I'd like to demonstrate another form of heat transfer, that is the heat transfer by the process of conduction. Here I have a Bunsen burner with a flame, and I'm going to put this flame directly under this copper rod, and we're going to watch the heat conduct on out the copper rod, and as the heat conducts along the copper rod, the various parts will get hot, and we'll see these rings of wax get hot enough to actually melt off. As the heat conducts along the rod, we see the first ring now starting to melt, and that ring will melt and eventually slide along and then drop off. And then the next ring will receive the heat as the heat continues to transfer along the rod by the process of conduction. So the rod is conducting heat from the flame along the rod, and we see those rings sequentially drop off. While we're watching for those rings to melt, let's try another little experiment here. Here I've previously heated some water up to a boil, and it's cooled off just a little bit, but this is hot water, and here I have another cup, and it says E equals mc squared on there. Now watch what happens when I pour the water from this cup, which has hot water in it, into this empty cup. I'll pour it in and fill it up about half full to start with, and then notice what happens to the surface of that cup. There's some paint on there that's sensitive to temperature. Now heat is being conducted from the inside of the cup to the outside of the cup, and we see as I fill it up now, more nearly full, then that heat is being transferred from inside the cup to the outside of the cup, and that causes the paint on the cup to change from E equals mc squared to a photograph of one of our favorite scientists, Albert Einstein. Now, in the meantime, we have heat being conducted along this rod, and I may have bumped that just a little bit. So the heat's being conducted along the rod, and we see we've seen that first ring melt, and now we see the second ring getting ready to melt, and it's already melted just about all the way through, and is getting ready to drop. And now we see the second one drop. Okay, now it looks like we have sufficient heat transferred along the rod now to where the third one is melted about 2/3 of the way through, and it's just about ready to fall. And now the third one has fallen, and heat is still being conducted along the rod, and the rod at any one particular point is getting hotter. It's hottest, of course, near the flame, coolest out at the far end, but eventually there'll be enough heat transferred out to the far end of that rod to melt that last ring off. Now, copper is one of the better conductors of heat energy, and we see that, however, even with copper, it takes some time for the heat to transfer from the hot part where the flame is out to the relatively cooler part at the end of the rod, demonstrating heat transfer by conduction. And now that last ring has fallen off, and the end of the rod is hotter than it was before, because it is hot enough to burn my finger here. Heat transfer by conduction. Now I'd like to demonstrate the relative conductivity of different metals. Here I have an apparatus with a with a copper rod here, a brass rod here. This rod is aluminum, nickel, and this one down here is an unknown alloy. And we're going to heat this up from the center and let the heat conduct out to the ends of each of these rods and measure which one has the greatest conductivity. That'll be the one for the wax ring to melt off first. So I'll heat this from the center, trying to heat up the center end of the center of this so that the inner part of each rod gets heated the same degree, and let the heat conduct out to the ends of each of those rods. And we now see copper is the first to go, so it has the greatest conductivity. And then aluminum, and then brass, and nickel, and then the unknown alloy. It shows that different metals have different conductivities, and it turns out that indeed copper is the best conductor of each of these 5 metals. Heat transfer by conduction.